During today's session, we'll be covering explanation of some phenomena using kinetic theory. Gas exerts pressure on container walls through constant collisions. These collisions generate force, and the pressure on the walls is the result of this force per unit area. Energy is needed to evaporate a liquid due to intermolecular forces. Only the fastest moving molecules possess enough energy to overcome these forces, necessitating energy to break them. Evaporation occurs due to intermolecular forces in liquids. Molecules at the surface, gaining enough kinetic energy from collisions, break away from attractive forces within the liquid, becoming independent vapor molecules. Cooling occurs as liquid evaporates because the departure of only the fastest moving molecules reduces the average kinetic energy of the remaining liquid molecules. In a draught, liquid evaporates faster as molecules leaving the surface are carried away, creating room for more molecules to escape, while fewer molecules return to the liquid. More surface area accelerates evaporation, as it provides additional space for liquid molecules to escape, resulting in faster evaporation and rapid cooling. Higher temperatures increase evaporation rate by enhancing average kinetic energy, allowing molecules to achieve greater velocities, overcoming attractive forces, and facilitating the evaporation process. When heating a fixed mass of gas in a container with fixed volume, increased internal energy accelerates molecules, raising their speed and kinetic energy. When a fixed mass of gas is heated in a container with fixed pressure, volume can be increased to maintain constant pressure. In short, volume increases with temperature and vice versa. When heating a gas in a container at constant temperature, Boyle's law, having the volume doubles the number of molecules per unit volume, resulting in doubled pressure. The kinetic theory explains diffusion by stating that, due to constant motion, molecules, particularly in a gas, rapidly spread from areas of higher to lower concentration. Thank you for watching. See you in the next video.